Hello, everyone, and welcome today to our monthly edition of Office Hours. This month is PHP Office Hours. For those of you who joined us for our Office Hours program before, I wanted to thank you for coming back and hopefully you enjoy this one as well. And for those who are not, I'm glad to introduce you to AWS's Office Hours programming. Before we get started, I wanted to mention that if you have joined today's webinar, you're muted. And you can listen in on your computer speakers or you can listen in on your telephone. You'll find both of those options in the attendee panel on the right-hand side of your screen. Also, during the presentation, we're going to invite you to ask questions, as we'll be answering a large number of questions today, and it's a main focal point of the office hour sessions in the questions panel. We're going to be collecting those and then, again, addressing them for roughly 30 to 40 minutes today. So without further ado, I'd like to introduce to you our two presenters today. The first is Jeff Barr. Jeff is a senior evangelist at AWS. He's based in Seattle, and he is the author of the PHP book, Host Your Website in the Cloud. Also joining us today is Ryan Parman. Ryan is a PHP development engineer who's also based in Seattle, and he's the creator of the PHP SDK. Again, just a little bit about what Office Hours is. Again, Office Hours is simply a program that we created that enables a technical audience the ability to interact with AWS technical experts. Again, this is our third session, and we're always looking to improve this program, so any feedback that you're willing to provide is greatly appreciated. What Office Hours is not is, first of all, Office Hours is not support. If you have a problem with your current deployment, please either visit our forums or actually our support website at the following URL, and you'll see multiple different support options for help with your current deployment. It's also not a place to find out about upcoming services. So as we actually are asking you to submit questions in terms of asking like what we'll be releasing or what's upcoming, since we typically do not disclose the information about our services until they're available, we will actually not be answering those questions. So today, with the Office Hours format, we always start off a little bit about what's new with the topic. So today will be what's new with PHP, with AWS, and then we're going to get into a couple how-to demonstrations. It's actually the first time with Office Hours we've added how-to demonstrations in, but we received feedback, and we think this is going to be a great addition to the program. Again, the two that we're going to cover today are Dynamically instantiated infrastructure and Scalable processing pipeline, and then we'll go right into the question and answer session. So right now, Ryan is going to jump in and take you through what's new with the PHP SDK.
Thanks a lot, Reed. So the AWS SDK for PHP launched at the end of September. Some of the very, very high-level features are that it has support for all of the major infrastructure services that AWS provides. It has some special features like batch requests, which is being able to execute requests in parallel to speed up your application. We have response caching, which will cache the responses that come back from AWS, so again, your application can run even faster. It uses simple XML to parse the XML, which is a very popular extension that's available in PHP 5, and it does a really good job of doing that. And we've made sure that it has as few external dependencies as possible. So just about anybody, whether you're on a $5 shared hosting account or AWS or something else, you can most likely use the SDK. That's about all that I have as far as new features and stuff. I'm going to go ahead and hand this over to Jeff.
Okay, so I'm Jeff, and we want to talk about some of the details of how you get started with the PHP SDK. The first thing that you need to do is you need to download and unpack the SDK. You put that in a directory, and then you need to edit your PHP configuration to put that directory on PHP's include path. Then you need to configure the SDK and you need, in the simplest case, you need two values. You need your AWS key and your AWS secret key. You get both of those by logging into your AWS portal, and you can simply find your credentials there. You then carefully copy those out of the portal. You paste those into, we give you a file called config sample inc.php. You copy that to config.inc.php, and you then edit the AWS key and the AWS secret key to put them in there. So that then gives the SDK the ability to access your AWS account and your resources. So that's the configuration. And then in each of the applications that you build, you simply need to require or include a single file. That file is sdk.class.php. So once you've done that, each of the different methods and functions that you can call in the SDK will return an object of type CF simple XML. So this is a representation of the XML that is returned from any of the AWS function calls. And in order to access this information, you simply need to traverse through the hierarchy of PHP arrays and objects and so forth. Now, when you dig in several levels deep, what you will find is that you'll find individual items that look like strings, but it's really important to know that those are themselves XML objects. They render as strings, but you need to cast them to a string type in order for them to be properly handled as a string throughout the rest of your application. So you can do that casting in two different ways. You can either, as you see at the bottom of the page, you can either put the traditional cast operator at the front of your expression, and in this case we're going several levels deep through the object to access we get the response object from the method call that we make. We then access the body of the response. We go to the contents array. We go to the first element of that array, and we then access the key value. So once we've referenced that, that's an XML object. We can either cast that to a string, or we can call the toString method on that object. And either way, you need to get this as a string. The little bit tricky part I've found is that if you don't cast it to a string, when you print it out, it certainly looks like a string. But then when you pass it to other parts of PHP, that other part says, I thought I was supposed to get a string, but I got this XML object. What am I supposed to do with it? So if you find yourself getting a little bit kind of surprising error messages from your code as you're working with the SDK, simply make sure that you're casting your XML values into strings. So let's take a look at two different samples, and both of these are actually things that I've first developed for my book. They've worked really, really well for audiences, and so I continue to use them and reuse them. The first example is about dynamically creating AWS infrastructure. So with just a little bit of code, we're going to create this simple architecture. We're going to launch an EC2 instance. We're going to create and attach a pair of EBS, Elastic Block Storage volumes, attach those to the instance, and we're going to allocate an Elastic IP address, and we're going to attach that to the instance. So I always like to contrast this to the traditional model of getting infrastructure, where you either need to buy hardware and install it in your colo, or you would need to actually call up your internet service provider, make an arrangement to get hardware. With AWS, you're simply making some function calls, and we'll see how to do that through the SDK in order to create this dynamic infrastructure. So let's see how to do it. So the first line of code, we're simply calling the SDK. We're creating an access object called an Amazon EC2 object. Now, there's two ways you can make this call. You can pass in your AWS credentials, but since we've already configured our SDK with those credentials, we simply pass, we don't need to pass in any credentials, and it'll use the set that we've configured in. That gives us an access object called an EC2 object, and we can then make method calls on that. So the second statement in the example here, I'm calling the run instances method. I'm passing in just a few values. I'm saying the AMI, or machine image I'd like to run, is the first argument. The second and third arguments represent the minimum and maximum number of instances I would like to launch. So I can say I want at least one, but as many as 10. If I need 10 or 100 or 1,000 instances, I can simply change that second one to a larger number. And then I pass in a few arguments. I want to be able to SSH to that instance once I've run it. So I pass in the name of my keys, and I previously created these keys in the AWS Management Console. And AWS has 11 different types of machines or instances, and I need to tell the run instances method that I would like to launch an M1 small instance. So I make that call, and AWS is going to go ahead and find some available hardware, install my operating system on it, launch that OS, make it all up and running and ready for me in the space of just a minute or two. So that call that I made returned a value that we captured as a variable called response. I'm then going to dig into that response and find some important information. I want two different values. The first is I want the instance ID, which is a unique value that identifies the instance that I just launched, so I can refer to it by that name in further calls. And the second one is the location, which we call the availability zone. So I need to know within the particular AWS region that we started this instance, I need to know which zone it is running in. So I dig through the return value, and I get the instance ID and the zone, and then I simply echo those out so I have a reference on where that was created. Now, with that information in hand, I'd like to get an IP address for my instance. So I call the allocate address method to do that. I use the isOK check to verify that I was able to successfully allocate the address. And then once again, I dig through the response and I assign the value public IP to the IP address that was assigned for me. So at this point, I have an IP address. It's part of my account, but it doesn't actually route to any particular EC2 instance. So the next step is to simply call associate address. And that one statement is all we need to do to connect the instance with a public IP address. We call that, we check to make sure that it's succeeded, and then we echo out that we've actually attached the address. So just a few very simple, very straightforward function calls. We can allocate hardware and attach the address. Now let's go ahead and create the virtual disk volumes. To do that, we'll call the create volume method twice. It just needs two arguments. The first is the size in gigabytes of the volume that we'd like to create, and the second is the availability zone. So we'll create a 10 gigabyte disk and a 100 gigabyte disk. Once again, check all the responses. After we've done that, dig into the responses and get the IDs of these created volumes. So we have volume 1 and volume 2 representing what was created. The next step is to simply attach these volumes to the instances, and we do that with the volume ID, the instance ID, and then we need to pass in a Linux device where that raw disk will appear. So now we've created these disks, attached them to our instance. If we were to go further, we would then log into the instance, we would attach a file system, or make a file system on that device, mount it up into our Unix file system, and then proceed. So there you see the power of the ability to create dynamic infrastructure. Okay, now the second example is a little bit more complicated, and I'm going to have to gloss over some of the deeper details of this, just due to the limited time that we have. This is another example I created for my book, and it's really turned into my favorite example because it shows really how simple it is to build a very scalable application. It shows that you can create a complex app like this in fairly small, easy to digest pieces. And it scales very, very nicely. What I have here as an application, if you look at that picture, you'll see that each of those white boxes represents an individual processing step, and each of the queues represents an Amazon SQS, Simple Queue Service, buffer between the different processing stages in this pipeline. So the big picture here is we're going to feed some URLs at the top into the URL queue. The first step is going to fetch the HTML at that location. It's then going to store that HTML in Amazon S3. And then it's going to pass the next kind of the workflow. It's going to pass the work along to the next step, which is to take that HTML, parse it, and identify any links to images that are found in that HTML. So as you see each of these different queues represented in the diagram, the queues store work to be done that's being passed from stage to stage to stage of this pipeline. So the second stage is going to go ahead and take the HTML from S3. It's going to parse it, find all the image URLs, and then write another record into the next queue to indicate there's more work to be done. The next kind of work to be done is to take those images, fetch each of those images from wherever they're found as referenced in the original HTML, store those into S3, and then proceed to write a work unit into the render queue. The render queue is going to take all the images that were found on that page, actually just the first 16 images, take those images, scale them down, and then draw, as you see on the right side of the page, just draw like a little montage or composite of all the images that are found on that page. So it's a really nice pipeline. Each of these different stages might take a longer or shorter amount of time based on the response speed of the website, the number of images to be fetched, the amount of work to be done to render them, and so forth. So if this was part of a production application, I could actually scale this in several different ways. I could choose to run each of the different processing steps on separate EC2 instances. I could even run multiple copies of any of these steps on the same EC2 instance across multiple cores, or I could run it across multiple EC2 instances. A really neat attribute of a pipeline model like this that's totally driven by the queues is the fact that there is no global state held in any local variables. All of the state, all of the work to be done is always held in a particular SQS message queue. So there's no ordering dependency. If this was part of a large application, maybe we had people submitting websites and we wanted to snapshot them, and tens or hundreds of these website requests were pouring in every minute, we wouldn't have to worry about doing things in order and running things at the slowest speed of the pipeline. We could tune the amount of processing power applied to each step by simply putting it on either different EC2 instances, different instance types, different cores, more cores, and so forth. So very simple example, but very scalable, very, very flexible. So let's dig in a little bit and see how it works. This is a bigger picture of the pipeline. We've already walked through most of this here. You can see the different steps that are involved. Now, when I was building this application, I designed the pipeline in some general terms, but I didn't have to actually write all the code before I was able to test it. I was able to get a sense of what I wanted to do, and then I built each step in turn, and then each step would do its work, leave its results in the next message queue for the next step of the pipeline. I would then implement that step and pull the data from step 1 to step 2 to 3 and so forth. So I was able to construct this pipeline pretty much as I outlined it on the diagram, building it step by step by step as I decided exactly how I wanted to make everything happen. So these are some of the really important attributes of this architecture. It's really simple, so each stage is very easy to understand. There's not a whole lot of low-level coding because we can rely on AWS and on the PHP SDK for that. Scalable in a number of different ways, adding processing, adding instances, adding additional stages if we want to make it more complex. And I don't have to worry about running out of space in message queues. I don't have to worry about storing too much data because we're using AWS and we can take advantage of AWS's scalability in several different ways. It's also a fault-tolerant architecture. Because of the way message queues work, the message queue remains in the queue until processed. If one of the stages were to be delayed or if the program crashed for some reason, those messages will remain in the queue until they're fully processed. If a process were to take a message from the queue, begin to process it, but then the process died for some reason, a very important feature of the simple queue service is that those messages will reappear in the queues after a configurable timeout period. And then finally, this architecture is asynchronous. Each stage runs at its own speed, and it's very, very possible to build, test, and run one stage at a time. So let's go ahead and look at the code and see how it was put together. I defined names for the different queues, the URL queue, the parse queue, the image queue, the render queue, and then the feed queue was actually another extension I didn't fully flesh out in this example. So these are simply the names of the message queues I'll be using. My first step here is I'm going to go ahead and create an access object for SQS, and then I'm going to use the create queue method to create those actual message queues. Now, one thing I found when I build these applications is that it's always worthwhile to put in a little bit of time up front to build some little debugging tools and some status tools. In this case, I made a tool that's called crawl queue status, and crawl queue status simply goes through each of the message queues and tells me how many messages are remaining in each of the queues. I find it's really worthwhile to build these up front and to put a little bit of extra time into making them have good error checking and high quality output, because they always turn out to be a lot more useful in retrospect than you would have thought in the beginning. Now, the way that the SDK and the way SQS works is that every one of the message queues in SQS has a distinct URL. So we have a little utility function called find queue URL that, given the name of a queue, lets us have the URL of the queue for processing. So all the other API calls that we make to reference a particular queue are always going to require the URL of the queue. So let's see how we go ahead and put a message into the queue. Now, a decision I made early on was that each of the messages in my message queues would be encoded in a very simple format called JSON, JSON. As I created each message, I decided I would actually pass along some history so I could have some very simple timing information in the message, and I could see basically the history of all the locations that message had been. So I could really trace each piece of work through my system. So you can see that I'm building a PHP array, and I put 4 different elements: an action telling the next stage of the processing what to be done. The origin was just to say where did this message originate. The data was the operation to be was the information to be processed. So in this case, we're loading messages into the queue, so the data would represent a URL. And then the history, as you'll see as we go through additional steps, was simply an array of locations of where the message had been. So it starts out and says posted by, the name of the program, and then a date and timestamp. To load the message into the first stage of the queue, we simply do a send message call. We pass in the URL of the queue and the message, and then we verify that that was actually passed in. So this is how we initiate our pipeline, by simply pushing a message into the first stage. So if you've built distributed message passing systems in the past, you know that it can be fairly complicated to glue all the pieces together. SQS and the PHP SDK, I think, make it much, much simpler. We post the messages, and then here's how we receive them. We create a little function called pull message, and we call SQS's receive message function with the queue URL. If we need to verify that we received a response. If we didn't receive a response, we simply sleep for 1 second in this case, and then we'll try again in a second. Otherwise, we can go ahead and process the message. So because we stored the message in JSON form, we need to decode the message with the JSON decode function built into PHP. And then this pull message function that I'm showing you simply returns a PHP array with a number of important values, including the timestamp, the actual message, the details, and then something called the receipt handle that we're going to need later when we actually need to go ahead and remove the message from the message queue. So we pull the message, and then each of the processing stages in my application looks the same. Okay? So what we do is we start with a while loop that runs forever. All that while loop needs to do is pull the message from the message queue, verify that a message was present, extract the details, and then do any processing on that message that will be specific to that particular pipeline stage. But this is effectively almost a base class, if you will, that's a pattern that would be repeated over and over in the different stages of the pipeline. Take the message, get the details, process it, and then in most cases we would then generate a new message and pass it along to the next stage in the pipeline. So here's just a sample of the detailed processing for a single stage. So this is the page fetch. So we have a URL called the page URL that we need to process. We then use PHP's file get contents to receive or to download the content of that page. Echo out a little bit of information for debugging so that we know that it worked. And then we're going to take that page and we're going to store it in Amazon S3 so that we can use it, reference it again later. Hang on just a second here. I accidentally clicked a little bit too much. Okay, there we go. Back to detailed processing. So in order to store in Amazon S3, we simply use our S3 access object, and we call the create object function. We need to mention where we'd like to store it in S3, a key for the object, and then we pass in what we'd like to store as the body, and then the ACL, or access control list, indicates the permissions that we would like to have on there. So this is a single detailed processing step. And then in the next step, the next final part of that processing, we take the values we pulled for the message, we augment the history with the fact that it's been through one more stage in the processing pipeline, and then we use send message to pass it along to the next stage. Now in the final step, what we're going to do some graphics processing. So this is in this particular step, we're not doing a whole lot of AWS. We've already done all the work to grab the different images in other steps I didn't show you. And we simply use PHP's GD library, which has functions such as image create from string and image copy, to take all the images we fetched and to draw those out onto our final tile. Okay, now I do have this all set up on my desktop, and with a little bit of luck, I'm going to show you how it works. It's a little bit complex to demo because I have 5 separate shell windows open. And that's not good when my network connection dropped. Okay, so I'm actually going to forego the demo because it would take me just a little bit of time to get all of these shell windows set up again. What I like to do is I actually have the application up and running in 5 different shell windows, and then I simply put the message into the queue at the first stage. And I'm actually running from home today, and my internet connection is a little bit under the weather. And it looks like my shell connections have become a little bit flaky here. So let's go ahead and turn over to Craig, who's going to start our Q&A session. And in the background here, I think I'm going to try to go ahead and get the demo up and running again if we want to try and do that a little bit later. So Craig, let's take off on the Q&A session now. And then during the Q&A, Craig's going to ask the questions for us. And then Ryan and I will cooperatively decide to answer based on who has the right answer.
Great, thanks, Jeff. Hi, everybody. My name is Craig Nolner, and I'm a program manager for AWS. And I've been collecting everybody's questions from the board. And Jeff, if you want to move us back over to the slides. Great, thanks. Ryan, do you want to start us out? What's the difference between using strings versus simple XML objects?
Well, as I think Jeff talked about a little bit earlier, it's really easy to confuse strings with the simple XML objects. We tend to get a lot of questions in the forums about this. And really the answer is it looks like a string, but it's not really a string, so you just need to make sure that you typecast it as a string before you try to use it and pass that data around to other method calls or to do other things in your application.
How can I get help?
How can you get help? I spend an awful lot of my day on the PHP forums, so feel free to go there, ask your question, and I try to get to those as quickly as I possibly can. Let's see, other stuff, other stuff, we also have a getting started guide. If you go to the aws.amazon.com website, go into our PHP Developer Center. We have some screencasts and tutorials. There's, of course, a link to the forums. We have getting started guides, a few other things like that. So that should be helpful for you.
Yeah, and those URLs, the direct URLs are going to be aws.amazon.com/php for the Developer Center, and then aws.amazon.com/SDK for PHP for the actual SDK. Next one up, describe instances is only giving me instances in the US East region. How do I get a list of all instances?
So for that, what you would do is describe instances is region specific. So if you wanted to get all instances in all regions, what you would have to do is basically make 4 separate calls, 1 to each region, and then collect the results that come back from that. If you go onto the forums, I believe that this question has already been asked, and I have already answered it. So if you want to search for describe instances, it should come up. You should be able to find the answer to that.
Great, thanks. Now I'm just going to skip over to a couple questions that have come in more recently. We'll just show this slide for now. Reed, this is a question for you. Okay, thanks for switching that over. What will the slides and the presentation be available at the end of the presentation? And if so, how long will it be available for?
Oh, absolutely. Thanks, Craig. Yes, they will be available. If you go to our homepage and you type in Office Hours into our search function, you'll end up at our Office Hours page, and we store all of the programs at that site.
Awesome. Next one up. How can I find out about upcoming events? Reed, do you want that?
Certainly. So if you're a current member, a current AWS customer, we actually send out newsletters that actually talk about all the upcoming events, such as this one. But if you're not, you can actually just go to our homepage again and click on the Upcoming Events tab, and that will have a list of all the upcoming events.
Great. Next one. Ryan, does the AWS SDK for PHP support Route 53?
Not as of today. That was a recently released service, and since that is one of our major infrastructure services, we do expect support at some point in the future, but it's not currently in the SDK.
Yep. Is there a way to invalidate Amazon CloudFront objects using the SDK, Ryan?
Absolutely. We added that, I believe, right at the same time as that feature launched in CloudFront. I'm not prepared to sit down and write code live, but it's pretty simple. I believe that, let me see, if could you guys click over to my screen or give my screen control? Okay, great. All right, so here I am at the AWS homepage. I've come up here to this nifty new search section that we've just recently launched. Searching for PHP. This first one, let's see, AWS SDK for PHP documentation. Let's come over here into the API reference. And we have a little search box up here. We also have a tree if you know exactly what you're looking for. But let's go ahead and just type invalidate. We have create invalidation, so hit the enter key. And this
hey Ryan, I'm not sure what you're showing is showing up on mine, but I guess the summary is definitely supported. We can help out by going to the reference documentation that's just available through aws.amazon.com/SDK for PHP. And Ryan was going to demo. Oh, there it is. Fantastic.
There it is.
Do you want to keep going?
Sure. Yeah, it's the create invalidation method on the Amazon CloudFront class. And if you scroll down here, I actually have an example of how to look at a at an S3 bucket that we're assuming is attached to distribution. And you can actually look through all of the objects or all of the files in the S3 bucket and add those to the list of things to invalidate in your CloudFront queue or your CloudFront distribution. So we have lots of examples throughout the documentation, and here's an example of how to do that.
Great, thanks. We'll go back to questions really quick. Another question we have is, can you use the AWS SDK for PHP to pass user scripts to configure an EC2 instance at launch?
I'm sorry, I think I just lost my questions. I can't see the screen. What was the question again?
The question is, can you use the SDK to pass user scripts to configure an EC2 instance at launch?
Yes. What we'll do is we have let me pull this back up again. Let me double check. I believe it's in run instances in the EC2 class. And we have an optional parameter here called user data, where you can pass in any data that you need directly into the instance and process it once it gets on to the other side. The example here doesn't include that, but it is listed here in the optional parameters.
Great, thanks. Next question. Is there a way to change the owner of an uploaded file if another user uploads it to the bucket?
I do not believe that is possible. I'm not 100% on that, but I'm about 90% on that. I don't believe that it's possible to change the owner once it's been uploaded. But I know that you can give access to other people using either IAM or bucket policies or ACLs. You can give access to other specific users, but as far as changing the actual owner, I don't believe that you can do that.
Correct. Yeah. Well, I mean, once it's uploaded S3, it has the same owner. Hey, Jeff.
Yeah.
I got a question for you. From your presentation, people were wondering what are the limits that Amazon SQS can handle with an incoming message per second?
Okay. So I don't think we've ever published an upper bound on SQS usage, but I've definitely heard of customers that are doing, I believe, in the several hundred messages per second posting to SQS. There is a distributed implementation behind SQS, so it should scale to handle fairly high message rates.
Okay, thanks. And one I'm just going to pull off right from the boards immediately. There's no slide for this. Jeff, can you recommend any beginner books for starting out with AWS and PHP?
Beginner as in more simple than what I already wrote about?
Oh, well, I think what are the available books?
Okay. Well, let me bring up the one that I would recommend here. So this is the book that I wrote last year and was published in late in the fall. So I'm not quite sure what beginner really means in this context. I do assume that the readers of my book do have some level of experience with PHP and some skills at the command line. And if that's what qualifies as a beginner, then I would say that you should be able to get some good value from my book. If I really didn't have the time to teach PHP or to teach how to use the command line in there. But we've gotten some pretty good reviews on the book so far, and people seem to think it does a good job of teaching them about AWS and how to get good value from it.
Great. Another question for you, Jeff. Could an EC2 instance send SQS to another EC2 instance in another different account? Does that?
Yeah, that certainly makes sense, and that's very reasonable to do. What you would need to do in that queue that's running in a separate account, you would need to use the policy language to create a policy that allows that external access. And there's actually a couple of different ways to do that, including something new that we just recently introduced called the policy generator. And I'm actually going to try to bring that up on the screen here. So SQS gives a lot of flexibility to let you control who is allowed to post. And using this policy generator, you can actually create policies for the different services, including an SQS queue policy. And you're able to do things like control who is allowed to send messages to the queue. And there's a very, very fine-grained control system on the SQS queues to allow, for example, you can control by who is account identity or by IP address. So you can restrict by time and so forth, as you can see in the policy generator. So yes, you have that control. So you can build complex applications that go across multiple AWS accounts. Now, depending on the complexity of what you build, I would recommend that you think both about multiple accounts and about using the AWS identity and access management to create multiple AWS users inside the scope of a single account. Sometimes things that in the past required multiple accounts can actually be solved more straightforwardly using the identity and access management.
Great, thanks, Jeff. Another question. How can you view the number of messages that are in that queue?
Okay. So I thought I actually had showed that. That there is a method to do that.
Mm-hmm.
I don't remember that. I think that's called, Ryan, do you know the name of that method offhand?
Oh, let me look.
We'll have to read the docs.
But the easiest thing,
That would be get queue size.
Yeah, and what that does is that reads, it reads from a property that's returned from another SQS call, get queue size, yeah. And that's an approximate size. Because of the distributed nature of SQS, it might not be 100% on, but it should be pretty close.
great, thanks. One more question. What use case would require creating Amazon EC2 instances programmatically?
Oh, wow, I can think of quite a few. In the simplest case, you would create them programmably to build a scalable site. So you might have some kind of an observer that's watching to see how busy are the existing instances, and like we could watch their network traffic or their CPU load, and then we could create additional instances and then use our elastic load balancer to spread traffic across all those instances. So that use case is actually so common. We have a service called auto scaling which dynamically creates instances to deal with an additional traffic load. You could also think of building deployment applications where maybe you have an application and you need to have EC2 instances for development, for testing, for deploying to multiple customers, and maybe you have a config file that says this is the set of instances I need, this is the set of disks, the set of IP addresses, and you can simply process that config file to say, and then create the instances based on information found in the config file. So the important thing is to now think of infrastructure as something you can create programmably, that it's something that is dynamic. And so instead of thinking of, well, I have this amount of processing power available to me and I need to then kind of restrict my work to whatever I can do with that amount of processing power, you think of processing power as effectively variable. You say, I'm going to just dial in as much or as little as I need, and if you can automate and do that programmatically, then you'll have a very scalable, very reliable system.
Great, thanks. another one for you, Jeff. Where is the auto-scaling in AWS? Is it programmatically only, or how do you auto-scale instances with you?
Several different ways to work with auto-scaling. So in the simplest way, what you do is you create a couple different things. You create an auto-scaling group, and you configure that auto-scaling group so it knows which EC2 AMI to launch. You give it some limits to say the smallest it's allowed to be and the largest it's allowed to be. And then you use our CloudWatch monitoring facility to create something called alarms. So the alarms watch various metrics collected by CloudWatch, things like CPU load, network traffic in, network traffic out. You configure these alarms so that based on a threshold value that you set, you can set a threshold that says if the average CPU load across all of my EC2 instances in the group exceeds, let's say, 75% for a period of more than 2 minutes, I'd like the alarm to fire. You then connect that alarm to the auto-scaling group with an activity that says increase the size of the auto-scaling group. So you use CloudWatch for the monitoring. You use the auto-scaling group to basically encapsulate this package of instances that you'd like to scale up and scale down based on load. And then you use the CloudWatch alarms facility to actually activate the group and say make it larger or make it smaller. So in addition to an alarm that says these systems are too busy, I need to make it larger, you can create another alarm that says the CPU load is so low when averaged across all the instances that that I can actually terminate some instances in the group and scale it down. So you can then build effectively a reactive system that you don't have to worry about manually bringing in more systems to deal with load. You simply configure your policies and your philosophy into the auto-scaling group and into the alarms, and then everything will happen automatically and appropriately based on how you set things up.
Great, thanks. Another question about EC2 and auto-scaling and related to programmatically launching instances. Can you assign elastic IPs to dynamically created instances?
Oh, certainly, yes.
Yeah. Then a question for you, Reed. Any hope that future Office Hours will have a broader set of supported client platforms, or what's coming next with Office Hours?
Yeah, so actually right now, when we conclude this Office Hours and we send a link with the recorded email, we'll actually be soliciting feedback for what our customers want to hear from this Office Hours program. So far, we've done one on Amazon EC2 and Amazon RDS. We're doing another product one, which is Amazon CloudFront, which will be next month. And then we're actually investigating what we might do in March. So your feedback would be helpful on that as we continue to sort of develop this program to serve the needs of our customers and potential customers.
Great. Thanks, Reed. Another question from the board. Ryan, does the AWS SDK for PHP support Mechanical Turk?
It does not currently support Mechanical Turk. The focus of the SDK is currently on infrastructure services. So we've tried to stay out of some of the other services that involve payments, or like Mechanical Turk, where it's using human beings as processing, essentially. Scalable workforce, I believe, is the term that's used. So right now we're focused just on infrastructure. At the same time, we make sure that we pay attention to what our users really want and what our users are asking for. So if there's enough demand for it, then that's certainly something that we'd be willing to take a look at.
Great. What about support for SNS?
Yes, SNS went out with the first version of the SDK back at the end of September. So yeah, it does include an SNS class that you can use to work with the simple notification service.
Cool. And then another question that just came in around backwards compatibility with the PHP SDK. Are new versions going to be backward compatible, or what is the goal?
Our goal is to remain backwards compatible as much as humanly possible. We sort of have a rule on our team, upgrades should not break existing applications. So that's backwards compatibility is something that we hold very highly. If there is something where we feel there's a greater reward compared to risk for an upgrade, what we might do is we might deprecate older functionality, but and then either give a timeline for when we're going to phase that out so that we give people an ample amount of time to make the upgrade or whatever else needs to happen. But as far as upgrades go, we make every effort to maintain backwards compatibility as we go.
Great, thanks. Jeff, question for you. Can you give me an overview of the advantages or, kind of compare using Amazon S3 versus EBS, especially in the case of your demo?
Okay, so they're really, I think they each have different kind of strengths. So to me, S3 was perfect for the demo because I didn't know if I was going to have to store several tens of files or several millions of files. So with S3, I was able to simply store what I have, and then S3 is going to be able to scale up to store as much as could possibly flow in there. There's currently something over 200 billion objects in S3, so adding in a couple hundred or a couple thousand for my app certainly isn't going to make a dent in the overall S3 storage. So S3 gave me that flexibility to use a little bit of storage or huge amounts of storage. And also, one important aspect I didn't even get a chance to demo was the fact that when we have objects stored in S3, each of them has an access control list. I can make those objects public, and then each of those objects has a URL. So I can store things in S3, and then I can publish that URL, and then I don't have to put the file onto a web server and deal with the actual care and feeding of a web server. So EBS strength is if you're going to access these files from an operating system. And if I want to use EBS, I would create a disk volume. I would then attach it to the instance. I would format it as a file system, mount it on a particular location in the operating system, and then I can read and write files just as if it was local disk to that particular machine. Now, as I think about the app that I reviewed, one of the real strengths of S3 is the fact that I'd be able to reference those same objects from multiple processes running on separate EC2 instances. Because of the way file systems work, when you create an EBS volume, that volume can only be attached to a single EC2 instance. You can't have two EC2 instances reading and writing from the same volume simultaneously. So EBS volumes are great when you need storage that's specific to a particular EC2 instance. You can disconnect it and connect to another instance at any time, but at a given point in time, only one instance is reading or writing to an EBS volume. So S3 also gives me this ability to reference that same information from several different processes and EC2 instances. I think that was a long answer to a short question, but hopefully that covered it.
Great, thanks, Jeff. A question for you, Ryan. Mm-hmm. The question is, could the presenters comment on any PHP integrated development environments that we've heard about or can be used effectively with EC2 and PHP development?
Are there any specific IDEs?
Yeah.
I think whereas languages like Java have pretty much settled on Eclipse and .NET has pretty much settled on Visual Studio, PHP is sort of the wild, wild west. There are a lot of people that use a lot of different IDEs. I've heard of people using Eclipse, Eclipse PDT. I myself use TextMate. There are a lot of them out there. There's a new one coming out for the Mac platform called Code that's still in development, but a lot of people are pretty enamored with it. So we don't currently have any developer tools published for any specific IDE, but the surveys that we send out to our customers asking for feedback We try to collect this sort of information to figure out what people are using so that we know where to spend our time in developing tools for developers and for IDEs and whatnot.
Yeah, if I can add to that, I mean, you could use any ID with AWS SDK for PHP, so it's not tailored to any specific environment. Just to add to that.
Mm-hmm.
Let's see here. Jeff, can you mount one EBS volume to multiple EC2 instances?
No, that is not allowed because the reason you can't do that is a little bit deeper than AWS. The real issue is that when you attach a disk to a computer and then access it as a file system, the file system implementation in the operating system, there's essentially this implicit understanding that it's the only one reading and writing to and from that disk. So if you were to have essentially the logical ability to create one volume and attach it to EC2 instances, that still wouldn't give you the desired result because you would need a file system that was aware of the fact that another instance was also reading and writing the data. And so that's something called a cluster file system, which there currently are not a whole lot of cluster file systems out in existence. So we currently allow only one reader, one writer for EBS volumes. Now we have had some discussions with vendors of cluster file systems about extending those to AWS, and there's some level of work we need to do in EBS and some levels that would be done in the cluster file system to be able to do that. I think there's one called GlusterFS that is able to build a kind of a shared disk volume across multiple instances and across multiple EBS volumes as well.
Great. What about how you might go about mounting an EBS volume automatically to the instance after it launches?
How would you do that? So that would be relatively easy. That's actually more Unix scripting than AWS work. If I was going to build that, I would simply, as kind of the next step in the code sample, what I would do is I would simply have a little loop that waits until the volume has been created and attached. Once that's done, I would then just use effectively a shell command to mount the volume to the to the instance, and then create the file system on top of it.
Craig, we have
Great.
time. Craig, we have time for just one more question.
Okay. Yeah. Let's do this one. Jeff, how can you access logs for files or objects downloaded from S3 and CloudFront?
Okay, so S3 and CloudFront both have logging facilities built in, and you do need to explicitly enable those for a particular S3 bucket or for a CloudFront distribution. Once they're enabled, what will happen is that when you enable them, you actually designate a separate S3 bucket as the recipient of the log files, and then the service will generate log files into that bucket in a standard Apache format that you can then download those log files and analyze them. So given that log files can take up an appreciable amount of storage, we really make it a separate option you can turn on, because as you're storing those log files, you're just incurring the regular S3 storage charges for them. Some customers need log files, and so they choose to opt in, and some others don't really need the log files, so they don't enable the logging feature for their buckets or their distributions.
Great. Well, thanks, Jeff.
Just to add on to that, I was just going to say really briefly, in the S3 class, there's a method called enable logging, and if you look up the documentation for that, it should be able to walk you right through it.
Great. Well, thank you so much, Jeff and Ryan. This really concludes our presentation today. I want to thank everyone out there for attending today's webinar and PHP Office Hours session. We're going to send a follow-up email, like I said before, with a link to this recorded presentation. And again, just on behalf of Amazon Web Services and our presenters, thank you so much for joining us today.
Thank you all for coming.